Throughout the history of organic chemistry, carbon-carbon bond-forming reactions have always had a special place in the hearts of organic chemists because organic molecules are made out of carbon, and so carbon-carbon bond-forming reactions have the potential to build up organic molecules in a systematic way. Typically, carbon-carbon bond-forming reactions are accomplished through the combination of a carbon-based electrophile, such as an alkyl halide or an alkyl sulfonate, with a carbon-based nucleophile. We've talked quite a bit about the carbon-based electrophiles in the past few webcasts, but now I'd like to take a look at some of the carbon-based nucleophiles that you're bound to see through your study of organic chemistry. The most common carbon-based nucleophiles are reagents containing a carbon-metal bond. And you can think of these almost as you think of a conventional inorganic salt. So for instance, sodium chloride we think of as being composed of sodium plus and chloride minus. In sodium chloride, the metal portion is the positive portion, and the non-metal portion is the negative portion. And for metal-carbon reagents, they are no exception. So similarly here, we see that carbon possesses a delta negative in the carbon-metal reagent, and the metal possesses a delta positive. A limiting resonance structure of a carbon-metal reagent shows the carbon with essentially a complete negative charge. And indeed, in thinking about the stability of carbon-metal reagents, or organometallic reagents as they're commonly called, we can remember back to trends we've learned for conventional anion stability. The carbon of a carbon-metal reagent acts essentially as a bare anion. Paradoxically, we can actually generate nucleophilic organometallic reagents from electrophilic alkyl halides through the process of lithium halogen exchange. So treatment of this alkyl bromide with lithium metal leads to the generation of a nucleophilic alkyl lithium species. And we started from an electrophilic alkyl bromide. However, the formation of lithium bromide drives the formation of this alkyl lithium reagent. Similarly, in the bottom case here, for the formation of the so-called Grignard reagent, treatment of an electrophilic aryl bromide containing a carbon-bromine bond there with magnesium leads to a product in which the magnesium has inserted into the carbon-bromine bond and rendered the sp2 carbon of that benzene ring nucleophilic. Another example of a Grignard reagent is shown here below, and we can see that treatment of this Grignard reagent with an electrophile, an epoxide, leads to opening of the epoxide under what are essentially basic conditions at the less substituted position to give us a new carbon-carbon bond. And so here we see how organometallic nucleophiles can be used to access that imminent class of carbon-carbon bond-forming reactions.